Hey everybody, this is linear regression with Python. What we will be doing in this video is looking how to implement linear regression or use a linear regression model with Python. Now we'll be using the module called Sklearn or the package called Sklearn to implement linear regression. So we won't be looking what linear regression is. We won't be looking into like what it means, what the internal details are. All we will look into is like how to implement given some random data set. How do we fit that data? How do we run some predictions and stuff? So let's start. What I'll start with is some basic inputs. I'm doing this on Jupyter Notebooks. Feel free to use Google Colab or just on a Python file. So we'll have our inputs first. I'm gonna say input numpy as np, so we need that. And we need to load a data frame, so we need pandas2 as pd, and then we might need matplotlib to do some plotting. So I'm gonna say matplotlib.pyplot as plt, and I think that's what we need. And we'll just hide all the warnings that we get. So I'm gonna say input warnings. I'm gonna say warnings dot filter warnings and ignore all the warnings that we get. Cool. And so that should work fine. Now, so if you don't have these packages installed, you want to install each of them in your system using pip. So you can say for numpy, you can just say pip install numpy, pandas, and similarly for matplotlib. Now we will define here a data set. So we'll use a very simple data frame, created using some dictionary. You could always read data, CSV files or JSON files, but for the sake of simplicity, we'll just use a very small data set. Now, say I have this dictionary, and it has, let's do this, and we have two items. So we're looking at the data set of number of customers visited on a day and the number of sales that happen on that day in a shop, right? Or any business. So let's say customer visits, and I've got an empty list here representing the values, and I gotta say the sales count, right? And we'll say an empty list for this. And in here, I can just say the customer visited just like 1 to 100. So let's say IDX for IDX in range of, let's say, 100. And the sales is, let's say, double for now, right? Let's say the sales is double, so I'm going to say IDX times 2 for IDX in range of 100, right? So I've got 100 rows, and if I need to convert this to a data frame, I can say df equals pd.dataframe of the data. If I do this, it should show me, okay, so say bracket closing error. I'll fix that. And if we see this should work fine. So we have two columns. We've got customer visits and we've got sales. We don't need zero customer visits. So I'll just say starting from 1. Or maybe you can just still do 250, right? I mean, that's much better. So 1, 250. And if we do look at this, we have some value here, right? So go 1 is 2, and obviously this, just to skew the data. We'll skew the data set in after once we complete the entire pipeline. So we have the data frame here. And what we need to do is use the linear regression model from sklearn to kind of create this. So what I'll do is, let's say, okay, we need one more library here, which is sklearn. So I'm going to say from sklearn import, I think from linear model. So it's sk.linear model, import linear regression, and that should get my implementation of the linear regression model here. And let's just call this linear regression implementation. Cool. And so what's my input here? So essentially linear regression is basically is a line trying to fit on the data set that we have, right? So if we have y equals mx plus c, or linear regression is basically a linear line fitting on the curve or fitting on the points. And so the idea is to kind of figure out the best m here, or m is the weight or the slope, we can say. And yeah, that's essentially what we're trying to do. We're essentially fitting a line through the curve or the points and find the best slope to kind of that represents most of the data set. And so what we will do here, so for our x, we have one value here or one column, which is custom visits, and our y here is the sales column. And so let's just do that. Once I say x, I can say is df of custom visits. I'll just keep this as a data frame. And that's why there is a double square brackets here. When you say this, you have a single column data frame. And my y would be this, which is the sales column, right? I'm going to say sales. And I've got my x and y. So just print x, you can see that. And my y would be this. And we have that there. Now to create or run the linear regression model, I need an object of the linear regression class. So I'm going to say linear reg equals linear regression. And I should get a linear regression object here. And I'm going to call the fit function to get or to run to fit the x and y values on the model. So I'm going to say linear reg dot fit, and let's just check the documentation for that. So I'm going to say linear regression, Sklearn. Let's see what we get. I don't remember the exact syntax, so we can say linear regression. Let's look at the fit function, which takes in array like or sparse metrics of shape and so basically the training data and the target values. And that should work, right? So if we pass this in, so let's just try and pass this, and let's just do this. Linear regression is not defined. I think I just run all these cells and we have our model here. So we fitted our x input values to and the y input values to kind of get the model. And essentially we can just create this equation, right? So essentially what we're doing, and we can get the this is basically, so the m, we can say m is the slope and our c is the y-intercept. So I'm going to say c equals y-intercept, and let's just see how to get that using the model. So I'm going to say, if I say dir of linear reg, I should be able to see all the methods that I can call on this object. So if you kind of look through these, you can say there's a coefficient, which is ideally the weight or the slope. And to get the slope, let's see the y-intercept, I can get the intercept method here. So what I'll do is I'll just remove this. I can say slope equals the linear reg dot, I think it's called coefficients. Let me just copy that and I'll put that there. And I can get my y-intercept using linear reg dot, I think it's called intercept. Let's just try that. And it's working. Let me just print both of them. I'll just say slope in here, and I've got a value there, and y equals and y-intercept would be some very small value, because like if you look at our data set, here's exactly the double, and so like essentially zero, right? Because it just fits, like the slope is, now our line is like this. So if I just plot this, essentially we just constructed our data set in this form, y equals 2x, right? That's pretty much easy to understand. And what I'll do is, so this is an array, right? So we just need to get the slope as an integer. So I'll do, or the numerical value. So I can say slope of 0, 0. And this, I'll do this. And I'll do the same with array y-intercept 2 and say y-intercept equals y-intercept of 0. And that should get me the values. If I say slope here, I get that, and y-intercept, I get that. So that's working. And what I need to do now, let's just try and plot this using matplotlib, right? So what do we need? So we have a PLT, you have imported matplotlib using PLT, and I'll just plot, let's say model, or let's say plot input data and linear regression fitted line, right? Let's just call that. and I can create an object. I think it's called fig comma axis equals plt.subplot, and let's just see if the syntax is correct. So that's there, and I can say so to plot x comma just point values. You have the scatter plot. I think let's just say matplotlib scatter plot. Let's just see docs. So you have these scattered plot, and you just provide the x and y values. So it's like float or array like shape n. So let's just try that. And we say plt dot scatter. Just see that. So that's what we got scatter and x and y. And so I'm gonna say x comma y. Let's just try this. And if you look at that, we have the exact. So I've got a lot of points in there altogether, squished. So I'll just okay, I'll just decrease the number of data points, right? It's so much easier to wait. So I'll just say 50, 50. Let me just see if that works. Okay, now we can see. I'm gonna just go into 10. Like we can see like just a couple of points, and I'll increase that. So I'll just say 10, and I'll just say run all cells, and okay, what's the error here? Okay, so 1 to 0, right? So this is wrong. And if you run that, so we got like 10 points. And we just need to draw the linear regression line now to see like how effective it's fitting. So I think we have a AX line. Let's just say matplot. Let's just search from here. AX. So we got like a plt.plot, or you can search for AX or dot, I think like AX line, right? And there you go. So I can do that. And you just pass in. So since we have the equation of the line, the slope and the y-intercept, we can construct the equation of the line using this one point and passing in the slope. So what I'll do is, so AX, yeah, axis.ax line, I'll just do this. I'll come back to Jupyter Notebook and say my axis dot x line, I need to pass in a point, right? And if we look at this, so if our equation is y equals mx plus c, right? And if I make my x 0, so I'll just put that x 0, I can say my y would be just equal to my y-intercept, right? So if I say this, y equals 0 plus, so like 0 times m plus c, plus c, and then y would just be equal to c. And so I kind of know the c is the y-intercept, and I've got that value there. So I'll just use that and say the slope is equals to slope, right? That's the variable I've stored that in. So I'll just try and run this and see if there's an error. So we can see that the line exactly fits, which is not what we want, but just for demonstration purposes, this works out. Now, let's see what we can do. Now we can just run predictions on our model, right? So let's say run predictions, and let's just search for that. I'm gonna say Sklearn linear regression. Just get that. And we've got the predict function to kind of lets us predict this. So I can pass in an array of n samples and n features. So basically you can pass in n rows of data and n features, like how many features that you have. And let's just try that. So I can say the linear edge dot predict, and I can pass in a x number of rows, right? And just so we just have one feature, so we can just send that one item in that list. So I've got this till 10, so or 9. Let's just see if we pass 10, we can kind of predict that this returns, right? So just use this and close the closing brackets, and so kind of predicts that's 20. Like that's obvious because in the training data we have like, hey, the sales is just twice of that, and that just predicts exactly the amount, right? And let's see what else. So yeah, so for linear regression we can just, for machine learning, right, we can always have some evaluation metrics, or compute the error. So we'll try and do that with this, right? In regression, let's say evaluation metrics, And let's do this, right? So we for regression, the evaluation metrics is like this: mean squared error, mean absolute error, and stuff. So let's just try and run this. So what I want to do is create a column in my df. So guys, I've got my data frame here. These are my actual sales, so sales are actual, and I can run my predicted sales column. Sales equals, I can say df dot, or say linear reg. I'll just do this. Let's say predicted sales equals linear reg dot predict, and I can keep passing my customer visits. Let's say customer visits this, and let's see what we get. So I've got li, and I can just pass this in here. Let's see if that works out. And if we have this, this returns us the predictions for our model. And what I want to do is, let's see, and let's just compute the error, right? So I want to compute the error. So I'll create a column for this. I'm going to say df of, let's say, absolute error. Absolute error equals df of, this would be the actual sales values minus the df of predicted sales. And let's see if we have those values, and it's like very small, obviously, like essentially zero. And we have that, and some of the other error values that we use are the mean squared error, right? Or these squared errors. I can just say these are the squared absolute error, right? Let's just call it squared error. And I can say this is absolute error times df of absolute error. Let's see if that works out. I'll call this df here. And this just becomes extremely small. And you could always compute the mean using numpy, right? I can say the absolute, I can compute the mean absolute error and all of this, but instead of manually computing this, I can actually import all of these error metrics from Sklearn, right? So I'm gonna go here and find the regression. I'm gonna say linear regression, Sklearn evaluation metrics. And see what we have here. So let's see scoring API. Let's find a couple of them. So got metrics, regression metrics, and we've got the module implements loss, several loss, core utility function. We can get mean squared error, got mean absolute error, we'll go the r square value there, and we'll just try and call those. So let me just go to, we'll just import it from here. I'm gonna say from, so just like Sklearn valuation metrics functions, valuation metrics functions f, just do this, and I can say from Sklearn dot metrics import a mean absolute error. And what else do we have? We got mean squared error, and we got the R2 score, or the R square value. We'll just run this using, we'll just see how to run these. And if we go to mean squared error, the function asks for the true values and the prediction values. And so let me just pass that. So I'll say MAE, we'll just call that this, and say mean, let's do this. So we have the MAE, and we just have to call the function mean absolute error. And we have what we need to pass in y true and y pred. So okay, y true Then we'll just define this here. Y true equals to df of, let's say, the sales, and y predicted, or let's say y pred equals df of predicted sales. Let's see if that works out. I think we just pass it as data frames, right? I think that should work. And equals to, I'll just print MAE, and let's see if that works out. And this prints the error. And similarly, we can always print the R square value, right? And let's just copy this. We'll just make this mean absolute or mean squared error. And this would be MSE, and I can say R2, let's say R2 val equals R2 score of y true comma y pred. And we'll just print that too. I'm gonna say R2 score. Let's say R2 val. Let's see if that works out, and that prints out, right? And R2 or R squared val, if it's 1, it's extremely good model, and if it's like 0, it's like literally no good, right? And this is how this works out. And let's see what else we can just do with this. Let's just try and mess the data set, right? I'm gonna say, instead of having this extremely fitted data, right? Let's just do this. And what I'm gonna do is, let's say get random val. Get random val. I'm gonna say this from random import randint, and I'm gonna say return rand in a value between 1 and 10, right? And instead of having exactly the double, I'm gonna say it's dx plus get random val, just to see what happens now. Random val, and we'll just run all the cells. Okay, we've got an error, idx plus. We need to call the function, obviously, to get the value. And just run that again. And now the line is kind of fitting in between. And let's see what we have. We got an R2 score of 0.4. It's like not really good, right, to be honest. And let's see, right? So if we just, let's say, predict for some input. So if you look at our input data set, let's see, we have the values here. We've got customer visits from 1 and 9, right? And because it's like some random skewed data, right? This is the sales that we get, and like very few rows, right? So let's see if we predict, or we can start a prediction. I'm gonna say on a new item. So I'm gonna say linear reg dot predict on, let's say if it's 40, or let's say 50, and let's say prediction, and let's see if that works out. Let's just print the prediction. And for 50 it's like 69, because like some random data set doesn't make any sense. So this is essentially what we have done. Like, so if you want to implement a linear regression model using Sklearn, this is all you have to do. You just have to import the linear regression model from the linear model, and you have the data set. You can always, do some cleaning. You can split the data set. So a couple of steps that we didn't do is, which, like, split the data set into test and train, when we have, a huge data set, and we just want to maybe do this on maybe 80% for train and 20% the rest of the remaining for test. And let's see, so we have this, we call the fit function to kind of, find the best weights for our line fitting the curve. And we can obviously get the coefficient and the intercepts using the dot coef function, or the method on that. And you can get the intercept using dot intercept. and we can always plot it, right? We can plot and see like, okay, how effectively is the line fitting the curve, and you can always check the valuation metrics using Sklearn. Valuation metrics have got mean absolute error, mean squared error, and R square, and I guess a couple of other valuation metrics. And yeah, so that's it for this video. Thank you for watching.